Hello guys, welcome to Infonity. This is your host Adam. So today's our topic is about black holes. Without any further delay, let's get started. A black hole is a region of space where the normal laws of physics break down. It is a region where the gravitational field is so strong that nothing, not even light, can escape from it. Black holes are formed when a massive star collapses at the end of its life. When the star dies, the gravity of all of its mass is concentrated into a single point, or singularity. The boundary around this singularity is called the event horizon, and it marks the point of no return for anything that gets too close to the black hole. There are three main types of black holes. Stellar black holes, these are the most common type of black hole. They are formed when a massive star collapses and are usually about 5 to 30 times the mass of the Sun. Intermediate black holes, these black holes are larger than stellar black holes, but not as massive as supermassive black holes. They are thought to be the result of the merger of two stellar black holes. Supermassive black holes, these black holes are the largest type of black hole, with masses that can be millions or billions of times the mass of the Sun. They are thought to be located at the centers of most galaxies, including our own Milky Way galaxy. Black holes are difficult to observe directly, but their presence can be inferred by the way they affect the movement of nearby objects. For example, if a black hole is located near a star, the star will be pulled toward the black hole, and its light will be stretched and reddened as it is pulled into the black hole's gravitational field. Black holes come in a range of sizes, from very small to extremely large. The size of a black hole is determined by its mass and its density. The smallest black holes, known as primordial black holes, could be as small as an atom but have the mass of a mountain. These black holes are hypothetical and have not yet been observed. Stellar black holes, on the other hand, are the most common type of black hole and are formed when a massive star collapses at the end of its life. These black holes are usually about 5 to 30 times the mass of the Sun and have a radius of about 15 kilometers, 9.3 miles. Intermediate black holes are larger than stellar black holes, but not as massive as supermassive black holes. They are thought to be the result of the merger of two stellar black holes and have masses that range from a few hundred to a few 100,000 times the mass of the Sun. Supermassive black holes are the largest type of black hole, with masses that can be millions or billions of times the mass of the Sun. They are thought to be located at the centers of most galaxies, including our own Milky Way galaxy. The radius of a supermassive black hole is proportional to its mass, so the larger the black hole, the larger its radius. It's important to note that the size of a black hole is not fixed and can change over time. For example, a black hole can grow in size by consuming matter or by merging with other black holes. Black holes are formed when a massive star collapses at the end of its life. When a star runs out of nuclear fuel, it can no longer generate the outward pressure needed to balance the inward pull of its own gravity. As a result, the star collapses under its own weight. If the collapsing star is massive enough, the gravity at its core will become so strong that it will cause the star to collapse into a singularity, a point in space where the normal laws of physics break down. The boundary around this singularity is called the event horizon, and it marks the point of no return for anything that gets too close to the black hole. It's important to note that the process of forming a black hole is not well understood and is an active area of research in astrophysics. Black holes can change in size over time, but they can't shrink to a smaller size than their event horizon, which is the boundary around the singularity where the normal laws of physics break down. The size of a black hole is determined by its mass and density. The more massive a black hole is, the larger its size will be. However, the density of a black hole can also affect its size. If a black hole has a high density, it will be smaller in size for a given mass compared to a black hole with a lower density. Black holes can grow in size by consuming matter, such as gas, dust, or other stars. As a black hole consumes more matter, its mass increases, which causes its size to increase as well. Black holes can also grow in size by merging with other black holes. On the other hand, Black holes can also lose mass over time through processes such as the emission of Hawking radiation. However, this process is extremely slow and is not thought to significantly affect the size of a black hole. In summary, black holes can change in size over time, but they can't shrink to a size smaller than their event horizon.